Let's talk data types. So far throughout the course, we've done a lot with data. We've done a lot with data. We've written so many queries, we've seen so many examples, but we haven't really gone deep on what these different types of data are. Before we create a full-fledged database, it's important that we know what types of data we can store in the database, because when we were writing queries, it was self-explanatory. The data was already there, the configuration was already there. But now that we're going to create our own database and our own tables, I think it's important to zoom out and then zoom in specifically on data types, because now we have to make decisions. And those decisions dictate how the rest of your data is going to look like. You are in control. You are the one making the decisions now. What am I going to store? How am I going to store it? What is it going to look like? And to do that, you need to know what's available to you. We've seen some data types that we can store throughout the course. We've looked at date and time. We've looked at Boolean, but we haven't had a comprehensive list so far. We haven't really kind of focused. When we talk about data types, we're talking about the types of data that we can store. Mo, that sentence is very confusing. I know. We're talking about types of data. And the best way we can describe this is kind of like buckets. In each bucket, we can store a specific type. When we looked at date and time, we're looking at a specific type of data. You can only store a date in there. Month, day, year, and time. And so the reason that a database categorizes it by types is so that it can put constraints on that data type. You're only allowed to store it like this. Now, why data types? Well, let's say that we were in the Wild West and everything was text. Well, how are you going to enforce that only a specific type of information can go in there? Are you going to trust the system that's inputting the data? Well, that's bad practice. You kind of want data integrity. You want your data to be of a certain type. So Postgres ships with certain types. And the data types in Postgres are categorized in these buckets. We can store numbers. We can store boxes of data, multiple pieces of data inside of a single box. We can store text. We can store date and time. We can store true or false, Booleans, or UUID types, which is unique identifiers, completely random pieces of data that are completely unique. And there are many, many more types, and you can go look at the Postgres docs if you want, and they'll kind of show you, hey, there are so many more types. We have geometric types to store geometric shapes. We can store network addresses, bits, XML, JSON, all these types, weird types that you may not have heard of, but it can store so many different types of shapes. And so what we're going to zoom in on and focus on is the core types that are used the most. And the reason that we're doing that is because these core types are the ones that you will use the most. When you go towards the complex end of typing, you're looking at storing very specific types of data, and you can always reach back to the docs to see what can I actually store here. And it's important to always read the docs, because they can alleviate some of the questions you may have. They can show you ways to do things that you may not have thought possible. When you come from a different DBMS provider, they may not have a UUID type specifically. They may not have arrays. They may not have these things. Older databases didn't store, for instance, arrays or boxes of data. They may not have had a UUID type specifically for unique identifiers. And their date and time types may be completely different. So it's important when you look at data types that you go not specifically off of what Postgres offers, but you go look at the docs based on what your DBMS provider allows you to store. And it's important that you go deep into that, because you need to understand what you can store and what the best practices are to know how to store something in that database. And so when we look at a data type is nothing more than a constraint placed on a field to allow only that type of data to be filled in. So just like we looked at date and time, the date and time field is nothing more than a constraint. We're constraining what's allowed to be filled in there, a date and a time, or text, or a number. We're saying, hey, only store this. And specifying a type is important because it tells the system how it can and should handle that data in that field. It's important for the system to know, hey, I'm storing text here, or I'm storing a date and time here, or I'm storing a Boolean here, true, false. Why should it know this? Because as the system has more information about what that data field is, it can be smarter about how it handles it. When we looked at indexes, well, when you index a type, the system needs to know what type of data is there so that it can be smart with that indexing strategy. The more information you give the system, the more the system can be smart with your data. So data types are extremely important for Postgres. If we just stored everything in plain text, well, we might as well use something like Excel. It is also important that it allows us to optimize our algorithms for processing the data by knowing its type. Like I said, the more information you give the system can give back to you as long as it has that feature set. That being said, data types are constraints on the data, so keep that in mind. Now, the first data type we're going to look at is Boolean, true, false. And we saw this in the 3-type value when we were looking at null values. A Boolean type can be true, false, or null in Postgres. Null is a valid value for Boolean. So true, null, or false. It can also do smart conversions. So when we look at this data type, well, it's true, null, or false. But when we fill it into Postgres, Postgres will accept different types of values in this field. So you don't necessarily have to say true or false. You could fill in 1 or 0, which correspond to true or false, yes or no, Y or F, true or false. And what Postgres is going to do behind the scenes is it's going to understand that this value maps to a certain conversion, and that is going to be true. And then when you request the data, it will return back the original value to you. So Boolean fields are smarter than just true or false. Postgres has gone ahead and made these smarter values. So Boolean type is true or false, and this can be used for many different applications. For instance, if you want to subscribe to marketing for a company, you could store that in a Boolean field, true or false, and that would tell the system, hey, I can send marketing emails to this person. Many different types of fields that you could choose a Boolean value for. The next value type we're going to look at is character. So let's zoom into that.